A load profile is just a fancy way of saying how is a system being used over time. Not just how much load there is, but also when it happens. How quickly it builds up, how long it lasts, and how it changes, because real life is not flat. Real life has patterns. And if we don't test those patterns, we are missing the point of performance testing entirely. So let's go back to our washing machine. Imagine you've just bought a brand new one, it's shiny, it's quiet, it even plays a little melody when it finishes. At this point, your expectations are high. And just like with software systems, expectations matter. Because performance is not just about speed, it's whether reality matches expectations. Now imagine it's a Tuesday evening. You come home from work, you look at your laundry basket, and it's not full yet. But there are enough clothes to justify a small cycle. So you run a light load. Everything works perfectly. No noise, no delays, no surprises. This is what we call a baseline load. It's the calm, normal situation. This can also be called a fixed load profile. This is your classic baseline test. A constant, predictable level of usage where nothing really changes over time. The system is under very little pressure, and this is usually where we feel comfortable. We think, okay, it works. But if we are honest, this tells us very little. It tells us the system works under ideal conditions, with minimal demand, without stress, or competition. It's like testing a system with one user. Clean data and no interruptions. Technically correct, but not very realistic. It's like judging your washing machine after washing 3 t-shirts. You haven't really tested anything meaningful yet. Now, let's move to something more realistic. It's the weekend. You've postponed laundry all week, like most of us do. The basket is full. Actually, it's overflowing at this point. Towels, jeans, hoodies, bed sheets, everything. This is not a gentle situation anymore. This is real life. You start one cycle, then another one, maybe a final one. What's happening here is that the load is building up gradually. In performance testing, we call this a ramp-up profile. The load doesn't hit the system all at once. It increases step by step, just like users arriving over time. You are now using the washing machine the way it was intended to be used. This is your load test. Here, performance testing starts to matter, because now we are asking, can the system handle the amount of work it was designed for? Does it stay stable across multiple cycles? Does performance remain consistent? This is a level where things should work. If the system fails here, it's not just a limitation. It's a problem. A system that cannot handle expected usage was never truly ready. For instance, you need to run the laundry before leaving, but you don't have time to wait for an hour. You push everything in one load and pushing the limits. Now let's take it a step further. Let's be a bit curious or maybe just impatient. You look at the pile of laundry and think maybe it will fit, so you push it in. Press it down, ignore all the warning signs and start the machine anyway. This is a stress test. We are now deliberately pushing the system beyond its limits. And very often, this kind of stress testing is also done using a ramp-up profile, where we keep increasing the load step by step until the system starts to break. So it's not just that we go beyond the limit, but how we get there that matters. At this point, we are no longer asking if it works, we are asking what happens when it shouldn't work. Because every system has limits. The question is not if it will fail, but how it will fail. Does it slow down? Does it start shaking violently? Does it stop halfway? Or does it pretend everything is fine while quietly doing a bad job? That last one is the most dangerous, because it gives the illusion of success while actually failing. In software, that's how salient data issues and hidden performance problems creep in. Now let's shift our focus again. Not to intensity, but to time. Imagine it's a long cleaning weekend. You've got energy, motivation, and a long list of things to do. You start laundry in the morning, then again in the afternoon, and again in the evening. The machine keeps running for hours. At first, everything is fine, but after a while, things begin to change. Maybe it gets warmer, maybe cycles take slightly longer, maybe small inefficiencies start to appear. This is what we call a soak test or an endurance test. We are testing how the system behaves over a long period of time, not under extreme load, but under continuous use. This is where subtle problems appear. In software, this could be memory leaks, resource exhaustion, or gradual slowdowns. These are dangerous because they don't show up immediately. They show up later in production when the system has already been running for hours or even days. Now, let's introduce a bit of chaos. Imagine you're not alone. Other people in your household decide at exactly the same moment to do the laundry. Or maybe you have guests staying over. Suddenly everyone needs the machine at the same time. Everything happens at once. This is a spike in demand. This so-called spike is what we call a spike test. A sudden, sharp increase in load. The system goes from calm to intense almost instantly. Now we observe how it reacts. Does it absorb the shock? Does it slow down gracefully? Or does it collapse under pressure? And just as important, what happens after the spike? Does it recover quickly or does it remain unstable? This kind of situation happens in real systems all the time. Think about moments when everyone tries to access something at once, like ticket sales for Tomorrowland. Everything is fine until it isn't. And then suddenly the system is under pressure it has to handle immediately. Finally, let's think about the long term. Your situation changes. Maybe you move in with someone. Maybe your family grows. Maybe your lifestyle changes. Suddenly, your laundry demand doubles or even triples. Now the question is no longer whether the machine works today, but whether it will still work tomorrow. This is scalability. Can the system grow with increased demand? Can it handle more users, more data, more activity, or does it hit a wall? Because at some point you will need to make decisions. Do we upgrade? Do we optimize? Or do we accept limitations? And these are not just technical questions, they are business decisions. Now, let's take a step back. All of these load profiles, baseline, load stress, soak, spike, scalability, they are not just technical terms. They represent real-life situations, real risks, real expectations. And performance testing is about understanding those situations before they happen in reality. Because once a system is live, it's no longer a safe environment to experiment. Users are already there, expectations are already set, and failures are no longer learning opportunities, they are incidents. Users don't analyze the type of load that causes issues. They don't say, oh, this looks like a spike-related degradation problem. They will simply say, this doesn't work. And that's what matters. Your washing machine has probably gone through all these scenarios already. You've tested it gently, pushed it to the limits, used it continuously, overloaded it, and shared it with others. And based on those experiences, you have built trust in it, or maybe you have lost trust in it. And that is what really performance testing is about. Not just speed, not just capacity, but trust. Making sure that when people rely on a system, it behaves in a way they can depend on. So next time you're doing the laundry, wait for that final spin cycle to finish. Take a moment to think about it. What you're really seeing is a system being used under a different load profile. A system being tested against real-life expectations, and a system quietly proving whether it deserves your trust.